there. Today we're going to be talking about similar triangles. Specifically, we're going to be talking about the idea of proportionality, finding scale factors, and setting up proportions or ratios equal to one another before the solving process. If you are looking for a video about algebra solving for ratios in the sense of we have some fraction set equal to an unknown in a fraction, if you're looking for help on how to solve this type of algebra, you're going to head over to a different video. But today what we're going to talk about is how and why we would even set up an equation that looks of that nature in the first place. So, first and foremost, what we've learned about similar triangles already in class is that similar triangles have congruent, corresponding, ooh, that was a weird thing that happened to my iPad, corresponding angles, and they have proportional corresponding sides. And what that means when they have proportional corresponding sides, we have learned is that that means that from one shape to another, to the other, I guess, all side lengths are multiplied by the same scale factor. So sometimes that scale factor is something that could be given to us, and there are other times when we're trying to figure out what that scale factor could be. So let's look at both scenarios. First, let's look at a situation where we know the scale factor. So we know the scale factor. I'm going to write SF for short for scale factor. So let's say, for example, I have a triangle here that I'm going to call ABC, and I know that I have a scale factor of 3, and my job is to figure out, we'll say identify. Oof. I don't know what is acting up about my pencil today. The side lengths for, and we'll say triangle DEF, if we know that triangle ABC is in fact similar to triangle DEF. So I've got triangle ABC here. Let's put some side lengths on that triangle. We'll have 3, 4, 5, because why the heck not? And now we want to figure out if we have a bigger triangle or another triangle that is DEF. I'll make it in a different color, DEF here. What are the side lengths on D, E, and F? So DE, what is that measurement? What is EF's measurement? And what is DF's measurement? So right away, what I need to be able to do is figure out what are the corresponding sides. So immediately I know that AB, the letters in the first 2 position on that first triangle's similarity statement, corresponds to the first 2 letters on that second triangle in the similarity statement. So that means that side AB corresponds to side DE right there. Those 2 sides are corresponding. I figured out that those 2 sides are corresponding. And we know immediately that the sides are proportional. So therefore that means I'm going to look for my scale factor to multiply this side length by to find my new side length. So I'm going to take my scale factor, which I know, and I'm going to take that side length, which I know, in order to find this new side length DE. So DE as a side length is going to be equal to, let's just undo all of that. That gets messy. This side length is going to be equal to the smaller triangle's side length. I don't know what is happening. 5 times the scale factor, which is 3, because like we've learned, from one shape to the other, the side lengths are being multiplied by that scale factor. So from this smaller shape, I take that side length, I multiply by my scale factor to get my new side length. So DE is now going to be a length of 15. We figured out. And now I'm going to move on and do that same idea with my next 2 letters of my similarity statement. So let's pick a very obviously different color. So now in orange, I notice that BC are the next two letters in my similarity statement, and EF are as well. which tells me that side length BC corresponds with side length EF right there. Those are the corresponding side lengths. So therefore, this time, in order to find the length of EF, I'm going to take the smaller corresponding side length, which is BC and 4, and I'm going to still multiply by that value of 3, that scale factor, to get a side length of 12. Finally, I have one more set of corresponding sides, and that would be my side length AC and DF. Those are corresponding as well, and therefore proportional. So now, what I'm going to do to find that third side length is I'm going to take the value AC, the smaller side length. I'm going to multiply it by the scale factor, which we know is 3, in order to find that side length for DF, which we know is 9. So in the end, this triangle has side lengths of 15, 12, and 9. Just like that. So when we know the scale factor, we take the side lengths on the triangle that we know things about, we multiply them by the scale factor in order to get the new side lengths. That's when we know the scale factor. The other situation that we could end up in is we want to find the scale factor. So let's talk about that one in green this time. We need to find the scale factor. So in this situation, I would be looking for that scale factor, which means I would know things about some shapes already, and I would have some areas labeled on both of those shapes. Or sorry, not areas, some side lengths labeled on both of those shapes. So for example, I might say that triangle XYZ is similar to triangle, I don't know, QRP, for example. Let's not put S in there because that'll get confusing with scale factor. So QRP and XYZ are similar triangles. So let me draw out some two triangles here. So this is going to be XYZ, and then here I'm going to have QRP. Now, in this case, let's go ahead and put some side lengths on these. So here's a 2, 3, 5, and on this one we'll go 10, 6, 4. So when I'm looking at this example that I've got here, both of these triangles have side lengths that have been labeled. I know how these triangles correspond to one another in their side lengths because I have this similarity statement here. So in the same way, those first two letters in that first triangle XY correspond to the first two letters in that second triangle QR. So I'm going to go ahead and just highlight to identify all those corresponding sides. So we know that XY goes with QR. We know that YZ goes with RP. And that XZ goes with QP, like that. So I've got the corresponding sides highlighted in different colors, and now we need to think about, to get from the triangle, from one triangle to the other, what did we multiply by? In some cases, you can think about this by just looking at it and eyeballing it, and that's something that we can do with this first example. So you can choose to go either direction. That is a choice that I get to make here. You choose the triangle to start with. So I could say I'm going to start at X, Y, Z and go to Q, R, P, in which case I need to figure out what did I multiply the side lengths of X, Y, Z by in order to get the side lengths of Q, R, P. Or I could start at Q, R, P, my goodness, and go to X, Y, Z. Either way is fine. But they're going to give you a slightly different scale factor, so we have to be specific. So let's go ahead, and I'm going to do it just for fun. I'm going to go a little bit backwards of maybe how your brain would want to look at this one, and I'm going to say let's use this. We're going to start at QRP, and we're going to say what would we multiply each of those side lengths by in order to get back to the side lengths on XYZ. So for example, we've got a few data points to look at. We know that we go from QR back to XY. So that is going from 10 back to 5. So what might be multiplying by there? Then we're going to double check that by writing it out for the other two side lengths as well. So from YZ, what might be me multiplying by to get, from RP, what might be we multiplying by to get back to YZ? So 6 goes back to 3. And then finally for that third side length on QP to get back to XZ, so from 4 back to 2. And at this point, hopefully we can eyeball this one and notice that you are taking 10 times 1/2 equals that 5, or in the sense of thinking about this as 10 divided by 2. So we're dividing by 2 or multiplying by that 1/2. And the same is true when you look at this. 6 times 1/2 equals our 3, and also 4 times 1/2 equals that 2. So our scale factor in this case, if we are going in this direction, our scale factor would then be 1/2 for the direction of starting at QRP and going back to XYZ. You can go the other way as well, in which case your scale factor ends up being reciprocal of that. So what I mean in that sense is instead of multiplying by 1/2 to go from 4 back to 2, if I was going from 2 to 4 in the sense of looking at these purple side lengths right here, if I'm going in this direction, then my scale factor is going to be 2 instead of 1/2. So we have to be careful and specific about the direction we are going, but both are possible scale factors here. If the problem states the direction to go, then be extra careful, but if you have that choice, make sure that we state that part as well. And that's an example where we can eyeball the scale factor.